Now, before we go into the actual solution, let me just take you through a couple of introduction towards what we are going to discuss here. First and foremost, I would suggest that you make a note of the graph here and try to visualize what's given, what's actually been explained here. Okay, so you have two cars, car P and car Q, and there's a graph that explains its motion. So try watching this a couple of times. I would suggest try watch it as many times as possible. Keep the question paper book in front of you and the solution book. Go through the question, read it while watching this, and try to figure out what is given in it and make a note of this. I mean, literally write it down. Okay, this is what you have understood from the graph. Okay, so I'll just leave this for maybe a minute here. Okay, watch it with me. Okay, now that you have watched it, okay, maybe I just show it to one more time. So let's go through this one more time. And after this, let's see a different form of the same graph. So this is the same, different graph of the same data that is given to us. Okay. So everything else remains same, except for the fact that the way it is represented is a bit different. Just show you that one more time. Okay. Maybe one more time. Let's go through all of this together. So we have graph one and graph two representing the same events taking place in the motion here. Okay. Now, what are the given conditions in the question? It is given to us that there's a car P whose acceleration is linear, which means acceleration of P with respect to time is kt, right? And acceleration of car Q is constant, therefore AQ is constant. Now, what is happening in real life? I mean, what is happening if we visualize this given data? At t is equal to 0, car P may start. Okay, maybe I skipped a point here. It is also given to us that initial crossing is at t is equal to 0. Okay, and we've been asked to find out the timings for two different crossings and different crossings that could happen. Now, at t is equal to 0, car P may start faster, which means the initial velocity of P would be larger. But car P's acceleration starts from 0 because A of P is 0. A of P at time t is equal to 0 is equal to 0. Oh, yes. Now, see, there are a lot of things that will not make in the first couple of, first 10 to 20 minutes of the solution here. Once we begin writing down the actual solution with integration and differentiation in it, then things will make more sense to it. Till then, just follow and write down what we're discussing. And at the end of this, I can assure you, you will be in a very confident state to solve any similar question that comes in the future. Okay? Please bear with me. Now, car Q may start slower, but it has a constant push from the beginning because AQ is given to be a constant. As a result, what happens is P goes ahead early itself. Why? Because velocity of P is greater than velocity of Q, and Q catches and overtakes later. Q catches early, and later when P's acceleration grows larger and larger, because it is a function of time, which is an exponential function of time, it increases with T. So P catches Q and overtakes the lead again. That creates up to 3 crossings. Okay. Now, not the general case that it will create 3 crossings. We're just taking a random example here. So this is the motion. Displacement of A, displacement of car P. What I'm trying to say is first we will discuss motion of car P alone. Okay, where we'll also consider car Q, but the whole discussion will be based on car P. And then we will discuss the motion of car Q, where car P will also be present, but the whole motion will be discussed primarily with respect to car Q. I'm sorry for the for this one here. And then we'll discuss what happens when the car meets at different time intervals. So this is happening at time t is equal to 0, right? And then the cars move ahead. P moves slightly, then P and Q meet again at time t is equal to t1. You see the displacements are same now. And later the cars moves further. And at time t is equal to t2, my bad, this should have come here. Anyway, the displacements are the same. And then the car P goes ahead of Q. So this is what we're trying to understand. And in the third method, what we'll do is we'll observe the car Q from P and we'll choose only one displacement, which is displacement of P with respect to Q. And this complete motion will be followed along with watching P from Q, which gives us this graph here actually. Okay, now see, I understand that things are becoming really overwhelming. It's close to 5 minutes, and you have not yet started the solution yet. Yes, I do understand because we are right now visualizing the given data. We are just trying to make it as much possible, a sense out of this given data. We are trying to figure out what is given to us. How can we understand? How can we try to make more clarity, to bring more clarity from the question here? Okay. Now, since that we've discussed the outline of the solution here, the visualization part, motion of part A, car P alone, motion of car Q alone, and then the relative motion, right? Let me give you one thing addition to this. We'll also try to solve this question using the concepts of graphs, which is very important. And in fact, the JE means is actually trying to see if you know the concept of graphs here. That goes without saying. But then I also wanted to visualize these data here. Okay, let's now move on to the next one, which is trying to visualizing the motion of P.